Welcome back, grade 10 students. This is teacher Hazel and I will be your math teacher for today. Are you ready for our next lesson? At the end of this video, you will be able to determine whether the given sequence is arithmetic or geometric. So before we start our lesson, let us have some activity entitled, Where Do I Belong? In this activity, you are going to choose from the box the missing term to complete the sequence. So we have number 1, we have 3, 9, 27, 81, and an unknown number here. We have number 2, two unknown numbers with second term 14 and third term 21. Number 3, we have the first term is missing, and so with the fifth term, given the third and fourth and fifth term. And then number 4, we have the first term. Missing numbers are, or the missing terms are the second and the third, given the fourth and the fifth term. Now lastly, we have number 5. We have 3, 11, third and fourth terms are missing, given the fifth term. Now, after answering the activity, we have questions. Now, the first question is, how do you determine the missing terms? How are you able to determine the missing terms of the given sequences? Second question we have, which of the sequence above are arithmetic and which are not? Given the 5 items that we had a while ago, which of those sequences are arithmetic and which are not? Now, can you differentiate geometric sequence from arithmetic sequence? If no, then today we will learn the difference between arithmetic sequence and geometric sequence. So the difference between arithmetic sequence and geometric sequence is set on this table. Let us start comparing arithmetic sequence and geometric sequence by their definition itself. So by definition of arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called a common difference. So from the definition of arithmetic sequence, we are going to obtain a term or the next term of a sequence by adding a constant. And this constant is called a common difference. Now let us have the definition of geometric sequence. Geometric sequence, on the other hand, is just a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called a common ratio. So by definition of geometric sequence, we will get or we will able to get the next term if we multiply any term or the preceding term to get the next term. And it is just not merely or not adding a constant. It must be a non-zero constant, and this non-zero constant is called the common ratio. So from the definition of the two sequences, we can say that we can obtain the next term in arithmetic sequence by adding a constant, and this constant is called the common difference, while in geometric sequence we're going to multiply a non-zero constant, and this constant is called the common ratio. Now, these two sequences varies in their formula. The formula for arithmetic sequence is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. While the formula for geometric sequence is a sub n is equal to a sub 1 times r raised to n minus 1. So basically, from their formulas, they are different. So those are the things that makes arithmetic sequence and geometric sequence different. To understand the difference between arithmetic sequence and geometric sequence, let us have some examples by determining which of the following sequence is arithmetic sequence and which of the following sequence is a geometric sequence. Also, if it's geometric sequence, find the common ratio, or if it's arithmetic sequence, find its common difference. Let us have example number 1. We have 2, -8, 32, and -128. In this example, observe that the sequence increases, specifically on the third and fourth term of the given sequence. Knowing the fact that it increases enormously on the third and fourth term of the sequence, we assume that this given sequence is a geometric sequence. So we divide any term by its preceding term to know if they have a common ratio. So we have -8 divided by 2. And we know that -8 divided by 2 gives us -4. Now let us try with the third and second term of the sequence. So we have -32 divided by -8. So we divide 32 divided by -8 gives us -4. Now let us try with -128 divided by 32. Now we divide -128 divided by 32 gives us -4 also. So observe that the common ratio is -4. Since the common ratio is -4, therefore the sequence is geometric. Now let us have example 2. We have 17, 11, 5, and -1. In this example, observe that the integers decreases, and observe that the difference of the integers doesn't decrease enormously. So having the fact that the integers or the difference between the integers does not decrease enormously, so we assume that the given sequence is arithmetic sequence. So given the fact that the sequence or the assumption is arithmetic sequence, so we subtract any term by its preceding term, starting with the second and the first term. So we subtract 11 minus 17, and 11 minus 17 gives us negative 6. Now, let's know if it's true for the third and second term. Now, let's subtract 5 and 11. We have 5 minus 11, and 5 minus 11 gives us negative 6. Now, let us know if it's true also for negative 1 and 5. Now, we subtract negative 1 minus 5, and we know that negative 1 and 5 are like terms. We have negative and negative here, so the answer must be negative, and they have the same sign, so we add the two. We have 1 plus 5 gives us 6. Observe that the difference between any two preceding terms is negative 6. Since the difference is negative 6, or the common difference is negative 6, so the sequence is arithmetic. Now let us have example 3. We have 29, 38, 47, 56, and so on. From the given sequence, observe that the difference between the sequence does not increase enormously. And also observe that the given sequence is increasing in increasing order. So given the fact that the difference does not increase enormously, so let us assume that the given sequence is arithmetic. So we subtract any term by its preceding term, starting with the second and first term. So we have 38 minus 29, which gives us 9. And let's try with 47 and 38. Let us subtract the 2. We have 47 minus 38 gives us 9 also. Now, let's check if it's true also for the fourth and third term. We have 56 and 47. Now, 56 minus 47 gives us 9. Observe that they have a common difference of 9. So, since the common difference is 9, the sequence is arithmetic. Now, let us have example 4. We have 3, negative 6, 12, negative 24, and so on. Now, observe that in our given sequence, the given sequence has an alternating signs. We have a positive, a negative, a positive, and a negative sign. Now, since we have an alternating sign, let us assume that this sequence is geometric sequence, because the difference between the given sequence are so big. So let us assume that the given sequence is geometric. Now, starting with the second and first term, we divide negative 6 divided by 3. We have negative 2, and then we divide 12 divided by negative 6. So we have 12 divided by negative 6 gives us negative 2 also, which is good. Now, let's try with the fourth and third term. We have negative 24 divided by 12, and negative 24 divided by 12 gives us negative 2. Thus, the assumption that we had a while ago that this one is geometric is true, because they have a common ratio of negative 2. And since the common ratio is negative 2, the sequence is geometric. Now, finally, let us determine if this sequence is geometric or arithmetic. We have our last example. We have negative 3, negative 15, negative 75, and negative 375, and so on. Observe that the given sequence, in this given sequence, it is in decreasing order. And observe also that in the third and fourth term, the difference is so big, or it decreases enormously on the third and fourth term. So let us assume that the given sequence is a geometric sequence. So we divide any term by its preceding term. We have negative 15 divided by negative 3 gives us 5. And also, let us divide negative 75 divided by negative 15. We have also positive 5. Now we have the negative 375 divided by negative 75. So we divide those two. We have 5. Observe that they have a common ratio of 5. So since they have a common ratio of 5, the given sequence is geometric. Now, do you have any questions? I would love to read your questions on the comment section below. Did you learn something? What have you learned? I would love to read what you have learned on the comment section below. Now, let us try. If you have learned something, let us have some activity which is entitled Get to Know Me. Now, in this activity, we are going to tell whether the sequence is geometric or arithmetic, right? The common difference or the common ratio. We have number 1, 4, 12, 36, 108, 324, and so on. Is this sequence arithmetic or geometric? If it's arithmetic, then write the common difference. If it's geometric, then write the common ratio. Now let's have number 2. We have negative 4, 13, 30, 47, 64, and so on. Now, is it geometric or arithmetic? If it's geometric, then write the common ratio. If it's arithmetic, then write the common difference. We have number 3, 3, negative 6, 12, negative 24, 48, and so on. Now, is it geometric or arithmetic? If it's geometric, then write the common ratio. If it's arithmetic, then write the common difference. Number 4, we have 3, 5, 7, 9, 11, and so on. Is it geometric or arithmetic? If it's geometric, then write the common ratio. If it's arithmetic, then write the common difference. Lastly, we have negative 3, 3, negative 3, 3, negative 3, and so on. Now, observe the given sequence. Is it geometric or arithmetic? If it's arithmetic, then write the common difference. If it's geometric, then write the common ratio. That's it! I hope you learned something. Thank you for watching, and I will see you on our next lesson.